So I'd like to start by saying thank you everyone for coming. My name is Cody Armstrong, and today we're covering the newly introduced FeatureScript. So if you haven't heard of FeatureScript, the idea behind it is a scripting programming language that allows you to define custom parametric features. So as always with these webinars, we really encourage you to ask any questions that you'd like. I'll do my best to answer any questions that you have. If I can't answer them, also on the line is Ilya Baran, and he is an expert in FeatureScript. He's the director of FeatureScript, and I think it's fair to say, without him, FeatureScript wouldn't exist. So absolutely the expert is on the line with us. Feel free to ask any questions that you'd like, and I'll do my best to answer them. If not, Ilya can help me out. So introducing FeatureScript, we're going to jump right into it. Now, what I want to stress is for those that aren't code writing experts, I want to walk you through how you can use FeatureScript as well. So I do want to spend a fair amount of time in how we use FeatureScript features, even if we're not code writing experts. So let's jump into things. Now, the first thing I want to point out is just a rough agenda of what we're going to be covering here today. And the big thing is, of course, I want to introduce you to FeatureScript. So what is it? How does it work? What was our goal with creating FeatureScript? And then I want to get into using FeatureScript features. So, how can you use features that others have created and maybe shared publicly or shared with you? The important thing to keep in mind with this is, again, any publicly shared FeatureScript features can be used by anyone. So it is a great resource, even if you have no intention of writing code. Now, if you do want to write your own features, then I want to get into how to do that. And that is, of course, using the tutorials and documentation that is available to us. So I'm going to walk you through how to find the documentation, how to find a tutorial, and then walk you through building a simple feature. We're going to create a simple FeatureScript feature live for you here at the end today. So that's kind of a rough agenda of what I hope to accomplish. Probably won't take the full hour, but again, feel free to ask any questions that you'd like. Now, a question that's popped up, what is the kernel language? This is the Parasolid kernel. Onshape uses the Parasolid kernel. So that's the rough agenda. Let's dig in. Now, introducing FeatureScript. What is FeatureScript? Well, put simply, it's a language for defining features, and in particular, custom parametric features. So it's an entirely new programming language developed by Onshape, and it's actually built into Onshape since the very beginning. Everything that we do today using the extrude, revolve, sweep, loft, all the standard features that you see in the features toolbar of your Part Studio is built using FeatureScript. So it really is the core functionality that allows Onshape to operate. So built into Onshape at the very beginning, it's already being used by millions. Millions of features have been created using FeatureScript. And that's because, again, it's that underlying code. When you click extrude, you're running FeatureScript. So all of Onshape's own built-in features are built using FeatureScript. And it's a scripting language that we use to build Onshape features, but you can use to build your own custom features as well. So that's a brief intro into the actual scripting language. What I'd like to do next is get into the differences. And one of the big things that I want to point out with Onshape FeatureScript versus something like SolidWorks or PTC Creo is we have a fixed list of tools, just like any other CAD application. So when you go to SolidWorks, for example, you have extrude, sweep, cuts, hole wizards, and so on. You have this fixed list of tools. So all parametric 3D CAD systems are based off of these features. Extrude, fillet, shells, all these commands that I'm sure we're all familiar with. But these features aren't typically open. They're built using internal source code that ties directly to their underlying features. And the idea behind FeatureScript is to allow the user, you out there, to see the same code that we use to drive the fillet command or the extrude command. So everything is about features with professional 3D CAD. The main difference between us and many others is that our built-in internal features are being publicly released so that you can build your own or build variations of it. So have you ever wished that a certain feature worked differently? Have you ever wished that the extrude command had a certain option, or that your revolve did a certain thing? Oftentimes what the end user will do in a traditional CAD scenario will submit what's often referred to as an enhancement request or improvement or something like that to the CAD company. And oftentimes it feels like you're sending that to a black hole. Just the slow nature of updates in traditional CAD applications, plus the priority taken to those kinds of things is often it's very demoralizing for a user. They submit an enhancement request and it doesn't go very far. And so the user will then end up trying something like a macro or an API. So you would end up either downloading a software development kit or using VBA, which is installed with SolidWorks. But the big thing is you have to build the user interface. They never quite feel the same as a traditional built-in feature. And you really have no idea what's going on in the background. What CAD company programmed the features and what those things look like. So the idea behind FeatureScript, and one of the things that we want to do is differentiate ourselves just slightly from a traditional CAD API. So if you think of a traditional CAD API, all CAD applications have their underlying code. And then in a traditional CAD application, the user interface ties directly to that underlying code. Traditionally, an API gives you a subset of those features and allows you to automate certain processes within the application, but generally limited to what's available in the user interface. And this means that you have a somewhat limited subset, and again, you end up having to build things like the user interface and so on. The idea behind FeatureScript, and the reason that the architecture is just a bit different, is the underlying code is still being generated, but on top of that is FeatureScript. And so FeatureScript is our application. And when you're running the extrude command, for instance, you're running FeatureScript. So you can think of the user interface as a layer on top of FeatureScript. So the big thing I want to point out, and I'm going to show you an example of this in just a bit, but you can start with Onshape's source code. This means you can look at the extrude command, the fillet command, the shell command, and you can view the source code for those features. Right? So here's a couple of screenshots I'd like to point out. But again, the neat thing about this is these are publicly available, and they're publicly available under an MIT license. So if you haven't heard of an MIT license, it basically states that you're free to distribute it, whether you want to distribute it free of charge or monetize it. Right? So we're trying to give the most permissive license we can, and in this case, that's the MIT license. So you're free to take the source code and reuse it, either for freely distributed features or for monetizing. The other thing that I like to point out with this is it is a tremendous resource for learning FeatureScript. FeatureScript code written by our developers is probably one of the cleanest examples or samples that you can take. So a great resource for learning. And you can literally copy and paste. So if I wanted to build my own extrude command, I can copy the source code for extrude, make my changes to it, and now I've built a custom extrude command. So again, we're publishing our source code publicly. I'm going to show you it in just a bit. Now, a few notes, a few things that I want to mention about security, and these are just a few questions that have come up. FeatureScript has limitations. Custom features cannot do certain things in the interest of security, and one of them is modify anything other than the Part Studio where that feature is used. So if you create a FeatureScript feature, it is only applicable to the Part Studio where you've used that feature. FeatureScript features cannot infect your Onshape account in any way. There's no way for it to access account information. Again, it's strictly about creating a feature. This also means that it can't communicate in any way back to the author. So you can trust code that is from an unknown author because, again, the limitations of FeatureScript state that it can't affect or can't communicate in any way back to the person that created it. So it can't communicate in any way, it can't infect your account in any way, but it's even further than that. It can't affect Part Studio regeneration if it's not in the feature list. So if you've added a feature and then deleted it, once you've deleted it, it no longer affects the Part Studio regeneration. And the big thing is, the worst that you might have to do is delete a feature from your feature list. If you don't care for it, if it, perhaps makes a slow rebuild time, you could just delete the feature and everything is back to the way it was. So again, it does not affect the Part Studio after it's been removed. The other thing I want to point out is it's not allowed, or it can't modify other features in the feature list. So it can't affect surrounding features with your feature. So there is a pretty limited set of functionality in terms of how it can access other bits of information, but the idea behind it is to make it as secure as possible. So just a note on security.
Sorry, Cody, let me jump in on that for 1 second. This is Ilya, by the way. So to be completely precise, it can't affect the definition of surrounding features. It can't change feature parameters of other features. But what it can do is certainly change what is in the Part Studio and have subsequent features regenerate differently as a result. So this is just clarifying.
Sure, thank you. So the key thing again is point out that once it's removed from the feature list, its impact is gone. So you don't have to be overly concerned about the security. We really limited the capabilities just to make it secure. Even in the case of untrusted authors, for example. All right, so one last thing, and this is an important note. You do not have to write code to use FeatureScript features. And I know I've already stressed this, but you do not have to write a line of code to use any of the publicly available features or to use features that have been shared with you. This means that you could hire someone to write a custom feature, or you could use any of the publicly available features that have been created. So again, you do not have to write code to use FeatureScript features. So let's jump into things. I don't want to spend too much more time in the slides. Let's jump into it now. In terms of resources for getting started, one of the first links that I would recommend, one of the first references I would recommend is our landing page, our web page for FeatureScript. It has a lot of great resources, a lot of great links to things that will help you get started. So if you're just getting started, you want to know what it is, how do I get, the basics, I would suggest checking out this web page. And you can find it on our homepage under CAD. You'll see FeatureScript. Now, the key things with this web page that I want to point out is it has the introduction video, which kind of walks you through what FeatureScript is, but it also has a link to each one of our featured spotlight features. And the reason I bring this up is these are all features you can start using today with no code writing whatsoever. You can add any one of these icons to your toolbar and start building spur gears or SAE ports or screw bosses. So all these are example features. The code is also publicly available, and I'll show you some examples of this in just a bit. But if you're just getting started, just keep in mind you can add any one of these. Also on the page is how to use custom FeatureScript features. So we're going to walk you through inserting or adding a FeatureScript feature to your toolbar and using it. Right, real simple video, just a minute, but it walks you through that process. And then if you're interested in writing your own features, we have a short video, which I'm going to walk you through a simple example, very similar in just a bit, but a short video on getting started. How do you create your first feature? There's also links to the documentation tutorials, the FeatureScript forums, a great place to get questions answered. So the idea behind this was we wanted to bring all the links and videos and content that we could regarding FeatureScript into a single place. I mentioned before, we're publicly releasing the source code for our entire library of features. You'll see the view the source code. If you click this link, it will take you right to the document and you can take a look at our source code. One last thing I want to mention is, we've have a number of examples up here in the feature spotlight. If you've written a feature and you're interested in having it spotlight, having it show up in this list, there's a link at the very bottom to submit your feature. We definitely recommend it if you're comfortable with giving your feature away and having it highlighted in the spotlight. Definitely let us know. We'd love to hear from you. So this is one of the first resources I wanted to point out. I may jump back and forth to this page just in a few different scenarios, but let's move on. And the thing I really wanted to focus on, the thing I wanted to spend some time on here is adding custom features to your toolbar. And so this is really intended for those that may not want to write code, but want to take advantage of all the features that have already been created. And there will be many more that you'll see featured. So how do we do that? How do we add one of these custom features to our toolbar and use it? So let's walk through that process. And we tried to make this as simple as possible. With the latest update, you'll see a Add Custom Features icon in the far right corner. If you click Add Custom Features, a dialog will appear with the option to add any custom features. Now, as I mentioned before, you can find features that have been shared with you, perhaps. You can browse using this simple, My Documents recently opened if you've created your own. But I think most important for those new users is the FeatureScript Samples filter. The FeatureScript Samples filter is a list of samples curated by Onshape that you can start using today. And so if I left-click FeatureScript Samples, you'll see a whole series of samples have been added. Right? You can use, again, any one of these today. And you add it to your toolbar, and now you have, for instance, a hex infill command or a point pattern. So let me walk you through a simple one. Let's add the spur gear feature. So I'll select FeatureScript Spur Gear. And then I select the Feature Studio within that document. And in the Feature Studio, I'm going to cover in just a moment. That's essentially where we write our code. So here I've got this spur gear feature. I'll left click. And if you'll notice, an SG button has been added to my toolbar. So in the top right here, next to the Add Custom Feature, you'll see any custom features that have been added to your toolbar. Now, a frequently asked question is, is this specific to the document? And the answer is no. This icon will be in your toolbar for all documents. So you'll see this icon in the Part Studio for all new documents and any documents that you open. Okay? So just keep that in mind. You are adding the icon to your toolbar for Part Studios permanently, unless you decide to remove it. And you can do that by right-clicking and selecting Remove. Okay, so that's all it really takes to add a custom feature. Now, if you want to run the feature, if you want to create a spur gear, like in my example, you just click on it, just like any other Onshape feature. Right, so you can select the SG button in this case, and you'll see it generates a spur gear. I have a dialog that appears, and you'll notice this is no different looking than any other Onshape feature. So the neat thing about this is you don't have to spend a lot of time building a user interface. I'm going to go over the examples in just a bit, but you get the same feel, the same feedback as an Onshape native feature, as an extrude or revolve or a loft, for example. So this spur gear example is very neat. I like it. You can just set number of teeth. I can set the pitch circle diameter, and very quickly generate a custom spur gear. You can define the center hole, and I can select a point, or excuse me, I can add a center hole and select a point with select origin. I can add keyways. I can set the extrude depth. There's all kinds of neat options, but the idea behind this is one feature that generates a spur gear. Right? If I hit the green check, you'll see a spur gear feature has been added to my toolbar. And so that's really all it takes to add custom features to your toolbar. Again, that command, that icon will be there until you remove it, but that's just a matter of right-clicking and choosing Remove. Okay. And again, there's a long list of features, so definitely check them out if you haven't already. I'm going to go through some of my favorites now, but I won't have an opportunity to go through all of them, so definitely take some time and check out some of the neat features that have been created. And again, this is just our first iteration, our first release. You're going to see that list grow. You're going to see new functionality being added to existing features. All kinds of cool stuff is coming. So that's adding a custom feature. Again, the Add Custom Features icon, just browse to the feature, and it's added to your toolbar. Let's move on. Now, what I'd like to do is go through some of my personal favorites in terms of the features that have been created. And let's start with that spur gear feature. Now, I showed you an example a moment ago where I created a simple spur gear, but here's an example where you have several spur gears, and they're all, again, just a single feature. The thing that I like to point out is notice that they're showing up as just another feature in your feature list, just like the extrude or the Boolean commands or the sketches that come after it. They can be reordered. They can be edited just like any other Onshape feature. Okay. So the spur gear feature, a really great command for generating all kinds of neat gears, including this ring gear you'll see the example of here. So very neat command, definitely worth checking out. Probably one of the most popular FeatureScript features that we have so far. And if you haven't looked at it already, definitely do so. Okay, so let's jump to the next one. And my next favorite example is one that I personally wrote, and that is the port feature. So if you do a lot of hydraulic SAE ports, this can be a valuable one to you. I just want to point it out here. Let's run the port feature. And I define my port size and any points that I want to add. So let's do a 1/220 port, and then I select the points that I want to add. The neat thing about this command, you can enter the depth manually. You can also select any sketch points, and it will use the normal direction of the sketch point to define the direction of the port. So I can select even ports going in different directions. Right? So SAE ports, real simple command. A neat thing that I like to point out with it is you can use any different plane or any different point on any different plane, and it will use the normal direction of that point to define the port feature. Okay? But again, real simple. Define the port size, define the points, set your depth, and then you have SAE ports. And this is SAEJ 1926. The thing I like to point out, though, is the example code that you'll see for this can be easily manipulated. So if you constantly create sun check valves, for example, and they have this constant port, you're always sketching this revolve profile, for example, you can very easily take this code and manipulate it to create that feature. So it's a very easy, kind of shell command that allows you to do a lot of different things just by changing something as simple as the vector locations for the port. Okay. So the key thing, again, the source code for all these examples that I've been pointing out to you is publicly available. So you can use them as examples for building your own features as well. The port feature, the spur gear feature, let's jump to that. You'll see this is the Feature Studio for the spur gear feature. If you want to take and manipulate that code and build your own version of it, you absolutely can. These are all publicly available. And that's the port feature. Again, a real simple example. The neat thing I like to point out about these documents is they come with a PDF at the very first slide. And the thing I like to point out is it kind of tries to walk you through it. So even if you don't know how the feature is used and you don't want to write code, this should be enough to get you started, to understand how it works and to create your first feature. So you'll see some notes, a prerequisite. The port feature requires you to have a sketch point, and one per port, and then you just select the point. Define the rotation axis as normal to the direction of the plane that the point was sketched on, and it creates an SAE straight thread port. Okay. So the idea behind it is trying to give the user, even if you don't have any code writing experience, the ability to grab this feature and use it very quickly. So jumping into my next example, the point pattern, and this is another feature I created that's very simple. All it does is it patterns parts at sketch points. So if you've ever had one of those scenarios where it's not a linear pattern, it's not a circular pattern, but you do want to take the same part and pattern it in several locations, oftentimes this point pattern can be useful. And again, all it really does, let's select the point pattern here, is I'll select the part I want to pattern, a reference point, right? So we'll select the bottom point here, and then any locations where I want to pattern that part. Okay, so I'm just selecting a series of points, and it patterns the part at those points. Again, a very useful command if you're trying to pattern a certain part, but it's not linear or circular. It's not an evenly spaced scenario. Very easy to use. The neat thing about it is the Boolean operations are supported, so I could choose add, define my merge scope as this part, and now I'm merging all those parts with my initial part. Right, so I only have one. You have the Boolean operations for remove and intersect as well. So if you're trying to do a cut, for example, you can use the point pattern your parts, and do a remove option. But again, the neat thing is it's just patterning those parts at sketch locations, sketch point locations. So those are just some of the features that we have. I have a couple more that I want to point out. With the point pattern code, definitely take a look at it. It's really, again, very simple. It's 60 lines of code that it took to create that feature. So I think from an end user perspective, even glancing at this code, the non-programmer might be able to figure out, what's going on here and how can I adjust it? How can I make changes to it? So that is the point pattern. The next example I'd like to point out is the rib. And this one is a very powerful rib command. This one is you can see from the code and you can see from the examples I'm going to show you, it really works in almost any situation. So let me go over the basics of it. Of course, we'll call up rib. And it's pretty straightforward. I select my sketch profiles and I select the part. It creates a rib. I can define the thickness, right? So there's 0.25. I can make it 0.125. I can change that very easily, right? So there's the rib. And that's a real simple example. It's just following the sketch geometry with a fixed thickness. But this command is much more powerful than just something as simple as that. Here's an example I like to give with the rib in a parallel direction. So here I've got this arc. We'll do a rib. I'll select the sketch profile, the part, and this time instead of normal to sketch plane, I'll choose parallel to sketch plane. Right? That will create a rib that again is parallel to the sketch plane instead of going in a normal direction. So it's just an option within the rib command, and there's my rib. Okay? Even though the sketch plane was parallel with this face and the normal direction was this way, it allows it to work. So it's not as critical where you place that sketch plane for your rib. Now, moving on, this again is very robust, and this is the example I'd like to show when we talk about complex geometry, where I'm trying to add a rib, but it may not be a perfect square, for example. Let me show you what I mean. Let's do a rib. I'll select this spline, the part, and there is the rib for that spline. Notice that it automatically ends at the edge of the geometry. So although the spline itself goes way beyond the geometry, the rib is intelligent enough to stop once it hits the end. Right? So again, a very robust command. It's even got the ability to select multiple edges, for example, and multiple parts. So now I'm creating one rib feature that affects two different parts in my part studio. Notice the depth is maintained, so it recognizes the parts that it's attached to, the parts that you select here, and it's intelligent enough to end the geometry correctly. Now, another option that I like to point out with this rib command, again, it's very robust, has lots of options to it, is this extend profile. So let's say, for instance, I select this line and I define my part as this box. Of course, by default, you would get what you would expect, a simple rib following the line. But you have this option to extend the profile up to part. And this allows it to extend the geometry automatically to the edges of the part. So you don't have to constrain the line on the exact depth that you want of the rib. It will automatically extend to match the part. So definitely very useful, worth checking out. It automatically detects any changes and goes out to the end of the part. And the ribs can be patterned. So you have linear patterns, circular patterns, all supported as well. This, again, I think is going to be one of the more popular features that are out there. So definitely check out rib if you haven't already. All right, so moving on, my last example that I want to show you here today is the fill pattern. This is just another frequently asked question. Do we have the ability to fill a face full of holes, for example, or certain features? And this fill pattern allows you to do that. So let's run it. We'll choose fill pattern. I'll select my face to pattern, which is this hole. I'll select the target face and a direction. Okay. It will then fill that face with the faces that I'm choosing to pattern. So in this case, I have a distance between instances of 25. Let's change that to 20. Okay. And I can set a border offset. So I can say, okay, let's keep these 10 millimeters away from any other edges. Right? You'll notice instances disappear around the hole. You'll see there's a 10 millimeter gap at least around all these holes, and now there's a 10 millimeter gap around the face itself. Okay? So just keep in mind these commands, very simple to use. You notice the interface is built just like our native Onshape commands, but very powerful capabilities. And again, the neat thing is the source code is all there for you. So if you want to take it and build something that's very close but a little bit different that matches what you're trying to do, you can absolutely do that. All right, so those are just some of the examples that I wanted to highlight. I wanted to try and highlight some of my personal favorites. There are 14 examples today, and of course that list is going to grow. So users will be submitting features. If you have any out there that you've written, we'd love to hear from you. But yeah, these are all available for you today that you can grab and start using to build your models. Now, what I'd like to do is get into actually creating a custom feature. And one of the first things I want to point out is the documentation. Now, just briefly, I want to jump back to our FeatureScript page. And the only reason I jump back to this is there are two links on the bottom I'd recommend checking out. Here at the bottom, you'll see Learn FeatureScript, which is a link to our documentation and the forums. So if you're interested in how to do a certain thing, the forums are a great way to get questions answered. And if you're interested in finding the documentation and tutorials for FeatureScript, this link will take you to that. Okay. So let's jump into it. Now, the link is cad.onshape.com/fsdoc, and this is kind of the home for all documentation, tutorials, and even some videos walking you through all the various pieces. When you're first getting started, this is kind of the Bible, so to speak. This is how you get started, how you go through and create, all your features, how you'll get started understanding what everything does. Some key links that I want to point out: there's a short video on creating a custom feature. It's a simple cylinder extrude, but it at least shows you how to get started using feature studios and snippets and so on. So real simple video to walk you through getting started. And then we have links to the tutorials, right? So you'll see the Start FeatureScript tutorials. If I jump into that tab, this is the Create a Slot feature, a very good feature to start with, written by our own Kevin O'Toole, who's in the FeatureScript team. And it's a great resource if you're just getting started with FeatureScript. It walks you through step for step with a video. Right? So if you're the type that wants to walk step for step, I definitely recommend this tutorial. Okay? So that's one of the first resources that I want to point out, and that is the Create a Slot tutorial. And you'll find the link to it at the top left here. Now, of course, the frequently asked question is, well, what about all the documentation for FeatureScript? What about everything that defines what you can do? And that is the standard library documentation. So the next, probably most important link for getting started is this link for the documentation. Now, this is one huge page. You'll find a definition for everything here. And the neat thing about it is you can do a Control F or Command F and do a search and quickly find the piece that you're looking for. So you don't have to scroll up and down if you know what you're looking for. Just do a Control F, Command F, and you can find very quickly what it is you're looking for. But one big document that describes just about everything that we have in FeatureScript, right? Everything that we can call up in FeatureScript. Probably one of the most important resources for those learning FeatureScript. Definitely keep in mind at the very top of the FS doc, you'll see standard library documentation. Okay, so very important resource. Now, the other important resource, the other important thing that I would recommend for those new users is the standard library source. And this is something I've already mentioned, but I do want to point it out. This is the source code for our features. So I mentioned before, we're publicly releasing the source code for our features. This is the source code for the chamfer command. And so if you wanted to build your own version of chamfer, you can copy and paste this code into your Feature Studio and build a variation of it. Under the tab manager here, you'll see if I scroll up and down, I have a long list of features. Right? So everything essentially in that Part Studio toolbar, you'll see a feature for here. Whole feature, helix, whole tables, loft, all kinds of various things that I want to get into. Now, a common one is, of course, the extrude command. So if I jump into the extrude command, it will take me to that Feature Studio. So with the slot tutorial, the documentation, which I've shown you, and this standard library of features, there's a lot of great examples of how to get started. So if you wanted to take, for instance, some code to understand how the extrude command works or build your own version, you can absolutely do that. You could copy and paste code and do whatever you'd like with it. And again, this is all being publicly released under an MIT license, which means you can distribute it freely or you can distribute it and monetize off of it. So this is our source code. I'd say, getting started, those are the big resources for you. We have the slot tutorial, the documentation, and of course, all the examples. And feel free as well to use the examples that others have released. So the spur gear feature, you can take a look at the source code. The fill pattern feature, you can take a look at the source code. So those are also valuable resources when you're getting started. So now that we've covered, what's available to you, definitely the FS doc is an important link to know, and you can find that at the bottom of our FeatureScript page here. You'll see Learn FeatureScript. But what about getting started? How do I actually create a custom feature? And what I'd like to do is walk you through a simple example of what I call the pocket fillet. And it just allows me, I want to create a feature that fillets every face associated with a pocket without having to manually select each and every face. And so this may be one of those scenarios where maybe I'm just trying to eliminate some tedious task, or I'm trying to automate some bit of my process. And I want to fillet, automatically everything associated with this pocket in one click. And right now, if I do a fillet and I select a whole series of faces, this could be a dozen different faces that I would need to select manually or use some kind of a create selection tool. So this is a great example where I might use FeatureScript to try and automate or improve my process. So let's walk through this. Now, the key thing I want to point out with creating a custom feature is that it's just another tab in your document. So there's no software development kit to download or install. There's really no steps besides creating that Feature Studio and writing your code. So how do we do that? I have my simple part. I'm ready to start writing my code. I go to the bottom left corner under Create tab, and you'll see Create Feature Studio. Right? That will create a new blank Feature Studio in our document. It's important to point out this is where you're writing your code. So again, the Feature Studio is just a tab within your document right alongside parts, assemblies, and drawings. You can version control it just like a part, assembly, or drawing. You can share it just like a part, assembly, or drawing. So the idea behind it is to use all the same tools you know and you use every day to also control your code. So here's a Feature Studio, and it actually gives me a bit of code to start out with. Just defines the version number for FeatureScript and imports the module for geometry. And this is kind of the standard when you first get started. Now, of course, what you'll need is to create a new feature. And there are a number of different tools to help out. So I want to point out both the new feature and all the various snippets that we have that can help you automate the process. So let's get started. Now, the first step when you're building a new feature is, of course, the new feature command. So I click New Feature, and it will add the framework to build a custom feature. Right? So you'll see annotation with the feature name. We'll give it a name of Pocket Fillet. I can define my constant. Let's say here I want this to be called Pocket Fillet. And then I can define what the feature actually does. Now, some things I want to point out. With FeatureScript, the user interface and the function's action are tied together. So you essentially have the top half of the code, which is your user interface. Then you have what actually happens when it runs, which is the function's action. And this allows us to create features that look exactly like Onshape features because, again, it's using the same dialogues. It's just simply taking what you put here and inserting into them. And then when it runs, it actually runs what you'll see in the function's action. So just keep in mind, you do have two pieces to your feature script, the user interface and the actual, actionable code. So let's get started. Now I want essentially to be able to click a face and enter a radius size and have it fill it everything associated with that pocket. That means that I need to have something that allows the user to click a face. And I can use a snippet to do that. So under the drop-down menu, under this very first drop-down for parameters, I can insert what we refer to as a query parameter. I'm just querying a face on my part. Right? So I'll insert a query parameter, and I'll call it face. Right? And we can say this is definition.face. So all I'm doing is inserting an annotation into my dialog that allows the user to click on a face. And you'll even see entity type face, max number of pix 1. So it's very easy to figure out what's going on here. So that's one of the first snippets. And again, there are many, many snippets here. You'll see all the various parameters, queries, all the evaluations, all the individual sketch functionality and feature functionality you'll find snippets for. Now, the next thing that I want to insert is a length parameter. Right? So I'll select a length parameter, and this is where I want the user to insert the radius size for my pocket fillet. Right? So we'll call this definition.radius. And so now I've inserted two annotations into my user interface. I want the user to select a face and then enter my radius size. So now we got to define what do we want to happen when this code runs. And so that's the function's action. So just below the annotations that I've defined with my query and my length parameter, now I want to define what happens. So the first step, let's define two variables. Let's say var faces equals, and I'm going to select Q concave connected faces. This will select everything attached or concave selected relative to my face. And so I'll say Q concave connected faces, and then we'll change the subquery out to definition.face. Okay. So now I'm saying whatever face I select, grab all the concave connected faces. Then I'll go var length equals definition.radius. Okay, so now I'm saying the variable length is equal to whatever the user inputs into the radius size. Now all I have to say is op fillet, and notice that I get the actual autocomplete. It recognizes that I'm typing op fillet, and I get a list of options. So op fit spline, op offset face, all these various options within it. So definitely the autocomplete is a useful function. Right? I can just select op fillet from the list, and it adds everything I need to create a fillet. Okay? So I want to define the fillet itself. You'll see I have context, I have the ID defining the idea of the fillet, but then I have what do I want to fillet? What are the entities that I want to fillet? So I'm going to change this from entities to faces. Right? I'm setting it equal to the faces variable. The radius I'll set equal to length. Right? And I want to add one more to this, and that is tangent, if I could type, tangent propagation. And I want to set that equal to true. Okay? So now I've defined my fillet. Now, a tip that I'd recommend for those users out there is you want to make sure that you're calling up the correct values here. So op fillet, for example, let's see if I got my values right.
You're missing a semicolon after the definition radius.
To the definition rate. Oh, I'm sorry. Simple mistake. Okay, so I've added that semicolon that ends that line, and there we go. That should resolve it. One last thing to point out. I'm done writing my code. I want to make sure to commit. Very important step. Make sure that once you're finished, you commit, and then you can actually use the feature. So let's actually use this. I've finished writing my code. I'm ready to use it in my Part Studio. I go back to Part Studio 1. Right? We'll jump back into that Part Studio, and what I'd like to do is use my feature. Now, you may have seen me using this icon in the past. You'll see custom features. This is how you'll select any custom features that were written inside of this workspace. So you'll see the icon on the far right. I click it, you'll see Pocket Fillet, and now I can select enter my radius. Again, notice the two annotations I defined, the length parameter and the query parameter. Right? So I'll enter radius 0.25, enter my face that I want, and it automatically fillets all edges associated with that face. So I'm clicking one command, and it fillets everything associated with it. Okay? And that just saves me from having to create selections or manually select individual faces in the feature. But what's really neat is, again, notice Pocket Fillet is added to the feature in the feature list, and that also means it regenerates like other features in the feature list. I can reorder it, and it will fail just like any other feature if I have any issues with it. It also means if I make a design change, it will update. So let's do that. Let's make a design change, and I want to add a simple circle to a corner. Now, even if I had selected a whole combination of faces, this still doesn't behave well if I had done this manually. But because I'm using FeatureScript and it's automatically grabbing all the faces associated with that face that I selected, it automatically rebuilds. And so this is the thing I wanted to point out is, FeatureScript features, the things that you generate, will rebuild right alongside Onshape native features, just like you see here. I didn't have to go in and edit the fillet and redefine faces. It automatically recognizes that the pocket has changed. So real simple example, but I wanted to point that out again. It's rebuilding just along everything else, just like the extrude command, or the revolve command, or the sweep or loft, right? So it rebuilds and behaves just like them. Again, if I want to change something, or just right-click and edit, and again, you get the dialog just like we saw a moment ago. Okay? So it's very easy for me to build a simple feature. And the key things I wanted to point out, you don't have to know a lot to get started. You'll notice I built that almost entirely using code snippets, inserting new features and inserting parameters. You can grab easily the various pieces of the standard doc and copy and paste them. In fact, if I go back here, if you hold down Control or Command and click on, for instance, Op Fillet, it will actually take you right to that section in the standard doc. So the neat thing is, if I want to know how Op Fillet works, here's the code that shows me how Op Fillet works, for example. So again, the command select or the control select will take you right to that section in the doc. So when you combine that with the snippets that we used, the autocomplete function, which gives you that look ahead capability and the ability to grab features easily, it makes it very easy to pick this up. And we tried to make this so that anyone can use it. Even the non-code writing expert has the ability to figure these things out. So that is really what I had planned for you. I know we're finishing just a few minutes early here. There are a lot of questions, and it looks like Ilya has been keeping up. So I'm going to stick around. We're going to stick around for a few minutes longer and answer any questions that you'd like. So feel free to shout out anything that you'd like, any questions that you have. But that's really it. Thank you, everyone, and have a good day.